Hands up, who's ready to try some past paper questions on statistics? Yeah! Well, hit it, Grace.
It's time for Maths with Mr. Thomas.
We are on Chapter 5 and this is lesson number 7. It's past paper questions based on statistics. So in this lesson, all I'm going to do is just go over a handful of questions that have popped up in past papers. It may help before the exam to look over these to check that you can answer the sort of questions they ask in the exam. So let's get stuck in. Ba 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 ba. Here we go. Here's a question from 2015, paper 1. Paper 1, does that mean it's non-calculator? It does mean it's non-calculator, yes. And it says the standard deviation of 12228 is equal to the square root of A. Find the value of A. Huh? But it says it's non-calculator. It does say it's non-calculator, which puts quite a few people off this question. But don't let it confuse you. What you should be taking from this is the fact that it is talking about the standard deviation. And when it's talking about the standard deviation, you're thinking about those two formulas on the formula sheet. Remember, there is one of them that I teach, one of them that I use, and one of them that I don't. The one that I use is this one here. So this should be jumping into your head. Boing, 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 boing. There we go. It's in your head. So that is what you're thinking, and it's saying the standard deviation is equal to root A. So we need to find the value of A, and to do that we really find out what the standard deviation is equal to. So to find the standard deviation, Grace, how do you do it? Work out the mean first of all. You are perfectly right. Yes, you do want to work out the mean. Remember, when it comes to standard deviation, the mean is denoted by X bar. It's X with this little line on the top. It's no different. The way you work out the mean is you get the total of all the numbers and then you divide by how many numbers you have. So if you add 1, 2, 2, 2 and 8, you end up with 15. You divide that by 5 because there are 5 numbers. And if you work out 15 divided by 5, you end up with 3. Well done, Grace. Thank you very much. So we have the mean. We're wanting to work out the standard deviation. So the next thing that you want to think is, it's that table. It is indeed, George. Yes, you are thinking about that table. That table is this one here. You've got the values of X. Then you work out X minus X bar, so X take away the mean. And finally, you've got X minus X bar all squared. So these values of X are just the values of X in the question. It's just these numbers here, 1, 2, 2, 2 and 8. So we write down 1, 2, 2, 2 and 8. Then what you want to do is you want to work out X, this number here, take away X bar, so take away the mean. So you work out 1 take away 3. Obviously 1 take away 3 is negative 2. And as I said in the standard deviation lesson, you don't need to write down 1 take away 3. That's just me showing you where you get the negative 2 from. So after that you would do 2 take away the mean. So you do 2 take away 3. After that is this 2 take away 3. Then it's this 2 take away 3. You're just taking away the mean from each of these numbers. And then it's 8 take away 3. Ba-ba-ba-bam. So you end up with negative 2, negative 1, negative 1, negative 1 and 5. Stop! Yes, Daniel, what is it? Remember, you can do your check to see if you're getting it right so far. You're perfectly right, Daniel. Yes, you can. So, Daniel, what do? You add the numbers up in that column and check that you get 0. Perfect, yes. What I would do then is if you add all these numbers up, negative 2, add negative 1, add negative 1, add negative 1, add 5, do you get 0? Yes, you do. Brilliant. You could also do 5, take away 1, gives you 4, take away 1, gives you 3, take away another one, gives you 2, and then take away 2, gives you 0. And that's what you get. Remember, this column should always be 0 unless your mean is rounded. Say you got 3.174825966 on a calculator, you would just be writing down 3 point whatever that was to 1 or 2 decimal places and then take that away. But because the mean would be out slightly, it means this would be out slightly from 0. But if it's not rounded, then you should always be getting 0. So that is your check. Thank you for the reminder, Daniel. You're welcome. After that, you take each of these numbers here, the X minus X bar, and you square that number. So you do negative 2 squared. So negative 2 times negative 2, 2 negatives make a positive, so you end up with positive 4. Remember, every single number in this column is going to be a positive value. Negative 1 squared is negative 1 times negative 1, which is positive 1. It's the same for this one, same for this one. And 5 squared is 25. After that, once again, get a total. So add up 25, 1, 1, 1, and 4, and you end up with, ooh, you're so good. It is 32. Well done. Now what we do is we go off to this equation from the formula sheet. And remember, it's saying the standard deviation is equal to root a. So we need to work out that it's going to be the square root of what? That what is what we're wanting to find. So if we sub things into that formula, well, just remember the whole of that top line is just this value here. That 32 is the sum of the x minus x bar squareds, and that's what sigma means here. It means the total. It's the sum of the x minus x bar squareds, and the sum was 32. So that whole top line will be replaced with 32. N take away 1. What's n? How many numbers you have? Good. So we've got 1, 2, 3, 4, 5 numbers. So it's 5 take away 1, which is 4. So we'd end up with the square root of 32 over 4. Yay, this is so simple. I know. After that, it's the square root of 32 divided by 4. Oh, the 32 divided by 4 can become 8. It can indeed. Yes, Jennifer, you are right. So you end up with the square root of 8. Yeah. Which means then, well, we end up with s equals the square root of 8. What lots of people then do is they think, oh no, how do you do this in non-calculator? You don't. It's saying the standard deviation is equal to the square root of a. In other words, the square root of something. We want to work out what that something is. And what this is showing us is that something is actually a. Because he's saying here the square root of a, and here we get the square root of 8. So it means that the value of a is 8, because it's square root of 8 and we've got the square root of a. So a has to be 8. Hopefully that makes sense. Yes. Good. Let's try another one. This is from 2019. Oh, so long ago. The olden days. It's paper 1, so once again it is a non-calculator question. It says the midday temperatures in Grantford were recorded over a 9-day period. They were in degrees Celsius, 4 degrees, 7 degrees, 4 degrees, 3 degrees, 6 degrees, 10 degrees, 9 degrees, 5 degrees, and 3 degrees. Part A, calculate the median and semi-interquartile range. And Part B, over the same 9-day period, the temperatures in Endoch were also recorded. The median was 8 degrees and the semi-interquartile range was 1.5 degrees. Make 2 valid comments comparing the midday temperatures of Grantford and Endoch during this period. Ooh. So, let's start with Part A. Calculate the median and semi-interquartile range. How could we do that, Jake? Help us out. Well, you just need to get the median, which is the middle number of all of these numbers. Yes, you're perfectly right, Jake. You are just wanting to get the middle value. That is how you'd go about getting the median. Sam, what's up? Remember, you have to put the numbers in order first of all. You do indeed, Sam. Yes, put the numbers in order. So the temperature's in order. If you order these from smallest to largest, you have 3, 3, 4, 4, 5, 6, 7, 9, and 10. That is those numbers in order from smallest to largest. You have to get them in order first of all. Well done, Sam. What you do after that is you can get the median and you can use that to get the semi-interquartile range. Remember, for the semi-interquartile range, you need your quartiles, Q1 and Q3. And Q2 is your median. So, let's do this. If we get the median by getting the middle number, you can probably tell what it is already just by looking at it. But if you can't, remember you can cross off 1 from the left and 1 from the right. 1 from the left and 1 from the right. 1 from the left and 1 from the right. 1 from the left and 1 from the right. And you can see here you have a middle number, which means the median is 5. That is your middle number. In order to work out Q1 and Q3, well, we've got 5, we've taken that out. That was our median, so we're ignoring that now. And what we want to do is we want to look at this lower set and this upper set of numbers. And Q1 is just your middle value of the 3, the 3, the 4, and the 4. So once again, I mean, it's probably obvious, but you can cross off 1 from the left and 1 from the right. And if you do that, you'll see you have 3 and 4 in the middle. When there's 2 numbers in the middle, just take what is halfway between them. And between 3 and 4, you have 3.5. Well done. For the 6, the 7, the 9 and the 10, once again, cross off 1 from the left and 1 from the right. You've got 7 and 9 in the middle, and you want to now then take the number that's halfway between them. Between 7 and 9 you have, good, it is 8. That's probably an easy one, but if you're unsure, you can just add the 2 numbers together and then half them. So 7 add 9 is 16, half that and you get 16. That's a way of finding out the numbers in the middle. If you want it slightly neater, that's it there. That is what you would do. Put the numbers in order, get the median, and then the upper and lower quartiles. What we are asked for, though, is to work out the median and the semi-interquartile range. Well, the median we have done. We found that to be 5. Woo! But the semi-interquartile range, we want to work that out. How do we go about getting the semi-interquartile range? Thomas, what do you do?
Well, you know, Q3, take away Q1. And do you divide by 2? I can't remember.
So we did Q3 take away Q1, you are perfectly right. But if you do Q3 take away Q1, that's known as the interquartile range.
Oh, so you do have it.
Yeah, you're perfectly right. The word semi. Think about a semicircle. It's half a circle. Semi means you are halving it. So you're halving the interquartile range. The interquartile range is Q3 take away Q1. But the semi-interquartile range is when you would divide that by 2. So Q3, our upper quartile, was 8. Q1, our lower quartile, was 3.5. So we do 8 take away 3.5 and then divide that by 2. 8 take away 3.5 gives you 4.5. Divide that then by 2 and you end up with, good, you get 2.25. Woo! Which means your semi-interquartile range is 2.25.
Yeah.
Part B, over the same day period, the temperatures in Endach were also recorded. The median was 8 degrees and the semi-interquartile range was 1.5 degrees. Make 2 valid comments comparing the midday temperatures of Grantford and Endach during this period. So, all I've done is I've taken the previous answers that we worked out. We worked out the median and the semi-interquartile range for Grantford. Woo! Expertly done. And we're told in this part B that in Endach the median is 8 and the semi-interquartile range is 1.5. When we're looking for 2 valid comments comparing the temperatures, well, we're wanting a comment on the median and another comment on the semi-interquartile range. Do you remember what the median shows you? If you do, then you should be starting off your sentence saying the median shows. That's how we would always start this off. Remember, the median is a type of average. You're perfectly right. Yeah, the median is a type of average. So in Grantford, you can say the average temperature was 5 degrees, but in Endach, the average temperature is 8 degrees. So comparing them, make sure you get the word average in when you're talking about the median. So again, I would say the median shows, and the median shows that on average, well, if you're looking at the averages, you can see it's lower in Grantford. So you can say the median shows that on average, the temperature was lower in Grantford over these 9 days. And you know that because it is these 2 numbers that you're looking at. It's the 5 and the 8. 5 is lower than 8, so the average temperature is lower in Grantford. As I've done with lots of the examples like this, you can always reverse that. You can say the median shows that on average the temperature in Endach is higher than in Grantford because the 8 is bigger than the 5. It doesn't matter which way around you have it, but make sure that you get the median shows that on average and then link it back to the question. It's talking about the temperatures in these places over the 9 days, and you know it because it's the 5 and the 8 that you're looking at when it comes to the median. So that would give you 1 mark. And for the second mark, you would get a mark for talking about what the semi-interquartile range shows you. So, what does the semi-interquartile range show you? Brilliant. The range, just the highest minus lowest, shows you the spread of the data. But remember, it's not that accurate because you could get outliers which put the data off ever so slightly. You could have one number that's far lower than all the others, or a number that's far bigger, so it doesn't give you a very accurate measurement of the spread of the data. The semi-interquartile range ignores any outliers, it ignores the top and the bottom 25%, and it gives you a more accurate spread of the data. So the semi-interquartile range shows the spread of the data, or the variation, how varied your results are. So make sure when you're talking about the semi-interquartile range, you get in the word spread or variation, or varied. So for this one, the semi-interquartile range, these are the numbers that you're looking at then for the semi-interquartile range. You've got the 2.25 and the 1.5. So you can see that because the number here is smaller than the 2.25, 1.5 is less, you can say that there is less variation in the temperatures in Endach. And you know that because the 1.5 is less than the 2.25. That is what you'll be writing down. And similarly above, make sure you say which one it is that you're using. Well, you're using the semi-interquartile range, and you're using that to show the variation. And again, link it back to the question. It's talking about the temperatures recorded in these places. So, semi-interquartile range shows there's less variation in the temperatures recorded in Endach, because 1.5 is less than 2.25. And once again, yes, you can always reverse that. You could always say instead, there is more variation in the temperatures recorded in Grantford. And it's a semi-interquartile range that shows that. So you can do it backwards if you like. So that is where you would get your second mark. Woo! Ready for another one?
Yes!
Then let's do it. Third past paper question. This is from 2018. Lovely year. This is paper 2, so a calculator would be allowed if you need it. A farmer's market took place one weekend. Stall holders were asked to record the number of customers who visited their stall. The number of customers who visited 6 of the stalls on Saturday were as follows. So there was 120, then 126, 125, 131, 130 and 124. Part A, calculate the mean and standard deviation of the number of customers. And part B, which we'll get to in a wee bit, the mean number of customers who visited these 6 stalls on Sunday was 117 and the standard deviation was 6.2. Make 2 valid comments comparing the number of customers who visited these stalls on Saturday and Sunday. So to start with part A, it's asking us to work out the mean number of customers. So how do you go about working out the mean? What do? Ellie?
You add all the numbers up and you divide by how many you have.
Yes, Ellie, you are perfectly right. So, when it comes to standard deviation, X bar denotes the mean, but Ellie was right. You add the numbers up to get a total, and then you divide by how many numbers you have. So, if you add 120, 126, 125, 131, 130, and 124, you end up with 756. Then divide that by n, how many numbers you have. There are just 6 numbers here, so if you divide that by 6, you can do that in your head if you like, or just boink, 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 doink. Key it in the calculator, you end up with 126. So your average, the mean, is 126 customers. You're also wanting to work out, though, the standard deviation. And when it comes to the standard deviation, you want to think about that table. And you need that table in order to use that formula. Remember, there are 2 formulas in the formula sheet for standard deviation. This is the one that I teach. This is the one that I prefer. I use that, so I just ignore the other one, and this is the one that I use. For this, you do need that table where you've got x, x minus x bar, and x minus x bar squared. And these values of x are just the numbers that you are told in the question. It's the number of customers at each of the stalls. With our table, you then want to work out x minus x bar. Remember, x bar is the mean. We worked that out in the last page. So it's 120, take away the mean of 126. So 120 take away 126 gives us negative 6. 126 take away the mean of 126 is just 0. 125 take away 126 is negative 1. Take the mean away for each of the numbers, take 126 away from each of these, and you end up with that column there for x minus x bar. Hold up! What is it?
Remember to do the check.
Yeah, you're perfectly right. You can always do a check here to see if you are getting it right so far. If you add all of these numbers together, the negative 6, 0, negative 1, 5, 4, and negative 2, what should you be getting? 0! Do you get 0? Well, start with the positive numbers. Well, you've got 0, so you can ignore that. You've got 5 add 4. 5 add 4 is 9. So then start taking away 2, 7. Take away 1, 6. And take away 6, 0. So you do have a total of 0. Woo! Remember that column should always be 0 unless your mean is rounded. That is a way to check if you're getting the question right so far. What you do now is you work out x minus x bar. So these numbers squared. So you do -6 squared, which means -6 times -6. 2 negatives make a positive, and 6 squared is 36. Woo! 0 squared is 0 times 0, which is 0. -1 squared is -1 times -1, which is +1. 5 squared is 25. 4 squared is 16. And -2 squared is 4. Well done. If you add all these numbers together, 36 add 0, add 1, add 25, add 16, add 4, you end up with 82. You do indeed, yeah. And remember, when it comes to that funky formula, this here, the sigma, means the total. It's the sum of the x minus x bar squareds. And there's x minus x bar squared. The sum of them, the total of them, was 82. So the whole of that top line is 82. Woo! So that's the square root of 82 over, and what does n take away 1? How many numbers we had take away 1? We had 1, 2, 3, 4, 5, 6 numbers. So take 1 away, it's 5. So it's the square root of 82 over 5. Woo! All we have to do now is just bang that into the calculator. Boom, 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 boom. And you end up with, remember to take the square root, you end up with an answer of 4.05. Yeah! Which means to answer part A, you would say there's a mean of 126 and a standard deviation of 4.05. High five, you. Yeah. Part B, the mean number of customers who visited these 6 stalls on Sunday was 117, and the standard deviation was 6.2. Make 2 valid comments comparing the number of customers who visited these stalls on Saturday and Sunday. So remember, this is our answer from part 1. On Saturday, we got the mean to be 126 and the standard deviation to be 4.05. For Sunday, well, it's telling us in the question, there's a mean of 117 and a standard deviation of 6.2. So we want to write down what that shows us. It is talking about making 2 valid comments. So when it talks about 2 valid comments, what it's really saying is, well, tell us about the mean and tell us about the standard deviation. The way I would always start these questions off is I would say the mean shows and the standard deviation shows. So what does the mean show us? Think back to what the mean actually is. What is the mean?
The mean is a type of average.
Good, so the mean is a type of average. So it's telling us the average number of customers on Saturday and the average number of customers on Sunday at these stalls. So if we're comparing these 2 numbers, we're comparing the means, so we're comparing the averages. So you can say the mean shows that on average, and looking at it, well, you can see that on Saturday there are on average more people visiting the stalls. So a sentence that you could write would be the mean shows on average there were more customers visiting the stalls on Saturday, and we know that because the 126 is bigger than the 117. Woo! Yes, as usual, you can reverse it. You can say the mean shows on average there were less customers visiting the stalls on Sunday because 117 is less than 126. Doesn't matter which way around you have it. As long as you link it to the question, it's talking about the number of customers visiting stalls, so put that in and make sure you're talking about the mean being an average and back it up by writing down which numbers you are comparing here. Yeah. The standard deviation. What does the standard deviation show you?
Well, that shows you the variation.
It does show you the variation.
All spread.
Good, so it shows you the variation or the spread. So it's a measure of how spread out the results are. So we're comparing these 2 numbers, and you can see for that the 4.05 is less than the 6.2. So you can say the standard deviation shows there is less variation because this number is smaller. There's less variation. Again, link it to the question. It's talking about the number of customers visiting stalls. So there's less variation in the number of customers visiting on Saturday, since the 4.05 is less than the 6.2. And as usual, yes, you can reverse it. You could say there's more variation in the number of customers visiting on Sunday, if you like, because 6.2 is bigger than the 4.05. But again, link it to the question, talk about the number of customers, say which one is less or which one is more, and make sure you talk about variation / spread. Those two sentences would get you the marks for that part B. Woo! Let's try one more past paper question. This one here is from 2019. Paper 1. So it's non-calculator? It is indeed. The fuel consumption of a group of cars is recorded. The scatter graph shows the relationship between the fuel consumption, F kilometers per litre, and the engine size, E litres of the cars. A line of best fit has been drawn. Oh, that's a lovely line. Find the equation of the line of best fit in terms of E and F. And part B, a Mars car has an engine size of 1.1 litres. Use your equation to estimate how many kilometres per litre he should expect to get. So, for part A, find the equation of the best fit line. Well, what you need to think for this is, so the equation of a best fit line is a straight line, so it's asking you to work out the equation of a straight line. Oh, for that then, are you thinking gradient? The y-intercept, a point, and the equation. You are indeed, yes, well done. So, in order to work out the gradient, you need 2 points. We're not told 2 points. Da-da-da-da. So we need to find 2 points on this line. So, looking at the line, it doesn't actually have to be 2 points that we are given. You can see that this point and this point lie on the line, but we don't actually need to use these. However, for this question, it probably makes sense to use them. You wouldn't start using 1 and then 15 point something. Don't just write down an estimate. Try to see these lines that the graph makes. Whoops. So that we cross there. Try to find points that go through these wee crosses on the graph, if that makes sense. So look at the graph and you can see that this point here is going, the line is going through that point there, and that point there would be, well, that's 1.5 and then 14, so you've got 1.5 and 14. You've also got the line going through, if you follow that down, there is crossing through this point here. So that point there would be, well, that's 3.5 and then going up 8. So we can write down our other point as 3.58. Just remember, to work out the gradient, it is y2 take y1 over x2 take x1. So, with the points, doesn't matter which way around you have it, but you've got an x coordinate and a y coordinate, and again an x coordinate and a y coordinate. Call one of the points point 1, so you get x1 and y1, and call one of the points point 2, so x2 and y2. If you sum the values in, y2 take y1 becomes 8 take away 14, and x2 take away x1 becomes 3.5 take away 1.5. Working that out, well, 8 take away 14 is negative 6. 3.5 take away 1.5 is 2, so it's negative 6 divided by 2, which is negative 3. So that is your gradient. Just do a wee check here. It is a negative gradient, which means the line sloping down. Yes, the line is sloping down. So you can check. So you probably are getting that right. To work out the y-intercept, well, we can't actually just extend the line up to see what it is. So what we have to do is we have to substitute the gradient and one of the points into y equals mx plus c to work out the value of c. So you can sub in m, which was negative 3, and one of the points, either the 1.514 or the 3.58. It doesn't matter which one you sub in. I'm subbing in the 1.5 and the 14. So I'm replacing y with 14 because that's what y is, and x here in this point was 1.5, so I'm replacing x with 1.5. So work that out, it means the 14 is equal to negative 3 times 1.5 is negative 4.5, add c. To get c just on its own, get rid of the negative 4.5 by adding 4.5 to both sides, which means then c would be 18.5. Yeah! So we've got the gradient, we've got the y-intercept, so now we just need to write down the equation. And for our equation, well, an equation of a straight line is always y equals mx plus c. And we want to replace m with negative 3 and c with 18.5. So we would have y equals negative 3 times x, negative 3x, plus the 18.5. Is that our answer?
No, it's not!
Is it not? Why not?
Because it says find the equation in terms of E and F.
You are right, Finlay, it does indeed. So, what do?
Well, because it wants it in terms of E and F, you replace X and Y with E and F.
Does it matter which way around you have it?
Yes, it does.
So, which one, Finlay, would it be?
Well, you can see the y-axis, going up and down, is not have a y beside it, it's got an F, which means the y becomes F.
Perfectly right. Well done, Finlay. And the X, well, if you look at the x-axis, you can see it doesn't have X written here, it's got E. So the X is being replaced with E, so we've got negative 3E. Add the 18.5. So that there is the answer to our question. It's the equation of the line f equals negative 3e plus 18.5. Just remember, whenever you do one of these questions, make sure if it's wanting it in terms of A and B, or C and D, or E and F, or M and Q, here it's asking for it in terms of E and F. So make sure you finish that bit off. And part B, a Mars car has an engine size of 1.1 litres. Use your equation. Oh, use your equation. That means that we're having to use that f equals negative 3e plus 18.5. Woo! To estimate how many kilometres per litre he should expect to get. How would you go about doing that then? Well, we're not actually wanting to use the graph for this. Bye-bye! What we're wanting to do is we're wanting to use the equation. So that here is the equation. How do we do it then? Well, it tells you the engine size. It tells you it's 1.1. It does indeed, yeah. It tells you it's an engine size of 1.1 litres, which means E, the engine size, is 1.1. So the fuel consumption would be F equals negative 3 times 1.1, because we're replacing E, the engine size, with what it says to be, 1.1, add to 18.5. If you do negative 3 times 1.1, you get negative 3.3, add the 18.5. Well, to do that, you could always do 18.5, take away 3.3. Either way, it means that F would equal the 15.2 kilometres per litre. Woo! There you go, Amar. Hopefully that helped. And hopefully that has helped you folks as well. I tried to pick out the questions that are fairly common, that pop up all the time, just to give you some practice. If you're needing more though, you could always try the TJ National 5 book. There's some questions there that I've picked out that are quite common exam style questions, and there's lots of other past papers there online that you can look at. Pick some of them out, give them a shot, just use your knowledge of statistics to solve these problems. Best of luck. Especially for the exam. See ya!